All right, let us begin. We're going to be working a problem from page 55. This is problem number 69. We know that there are two cars in this problem, car A and car B. At time 0, when no time has passed, and we begin our investigation of these two cars in their motion, we see that car A begins at an initial position that is in front of our reference point by 48 kilometers. You can think of it as a 48 kilometer head start. We don't know the initial position of car B at time 0, but we do know that after half an hour, car B is at the reference point of 0. We know the speed of car A is 36.0 kilometers for every 1 hour. We know the speed of car B is 48.0 kilometers for every 1 hour of time that passes. Our question is, when does car B pass car A? To begin answering this question, what we would want to do is make a graph. Before we can graph, we need a set of data points that will describe the position versus time for both of these cars. The intersection of those two lines shows us the point at which car B overcomes car A. We'll make the data tables on the right side here. Here's for car A, and then for car B, time and position. Two data tables or T-charts. For car A, it'd be easy for us to start at time 0, because we know at time 0 he starts at a position of 48 kilometers. After 1 hour, he travels another 36 kilometers from his initial 48, and so he ends up at 84 kilometers. After 2 hours, we add another 36, right? Here all we did was add 36 because of his speed. We see he's at 120, and we continue this pattern. We'll continue it up to 6 hours. We see that 120 plus 36 is 156, then 192, 228, and finally 264 kilometers. We can do the same thing for car B, except we don't know at time 0, we only know at half an hour or 0.5 of an hour that he's at the position of 0 kilometers. After 1 hour, where is he? Well, if we know his speed, we know if we take car B's speed times the amount of time, or the difference in time between one point to the next, then we can find the distance that he traveled. We know that the speed of car B is 48.0 kilometers for every 1 hour. Well, he didn't travel for 1 hour from point 0.5 to 1 in terms of time. He traveled 1 minus 0.50, which would be a time of 0.50 hours. Our hours cancel, and we end up with 24.0 kilometers. This T here represents the change in time from one point to the next. So we start at the end point of 1 hour minus 0.5 hours, and that gives us a change in time of 0.50 hours. That's the time that we put here. The difference in this point to that point. So after 1 hour, we've traveled 24 kilometers. Now after 2 hours, well, what's my speed? Well, for every 1 hour that passes, from the first hour to the second hour, 1 hour has passed. So I add 48 kilometers for every 1 hour that passes. Oop, my bad. This should be 24 plus 48, right? 24 plus 48 is 72. We'll fill in our whole data chart all the way to 6 hours. We'll see that at 3 hours, he's at 120. At 4 hours, he's at 168. At 5 hours, 216. And after 6 hours, 264 kilometers. Notice that at the point in time of 6 hours have elapsed, we see that they're both at the same position of 264 kilometers. That's what our graph should show. We'll see if the graph demonstrates that. We'll start with my vertical axes for my dependent variable, which is position, and then my horizontal axis, which represents my independent variable of time. Time measured in this case by hours. And my position, or my dependent variable, is measured in kilometers. I need a total range of 6 hours on my horizontal axis, on my independent variable axis. Looks like I'll get those 6 hours just fine. I need a range, or I need a position, a vertical axis, a dependent axis that goes all the way from my smallest value to my largest value. So from 0 all the way up to 264. If I put together here, this would be 1, 2, 3, 4, 5, 6, 7, 8 tick marks. If I made each tick on the position axis, on my dependent variable axis, 40, then I'd have 40 times 8 ticks, which gives me 320 kilometers. That covers my whole range. So that is an appropriate use of the distance between each tick mark. All the way up to 320. I'm going to plot 3 points from each of these graphs, or each of these data tables, and then draw a line of best fit through them. I know that each of these should be a linear relationship between time and position because I have a constant change in my dependent variable as I see a constant change in my independent variable. In other words, the slope, or the ratio of these two variables as they change, remains constant. That's how I know I have a line. I'll start with car A. At a time of 0 hours, I'm at 48 meters. At a time of 2 hours, I'm at 120 meters. At a time of 4 hours, I'm at 192 meters. 4 hours, 192. Should be just below the 200 mark. And now I'll go ahead and connect these 3 points. All I actually need is two points. Would be enough. This is the graphical linear relationship for car A. Now I'm going to draw it for car B. At 1 hour, I have 24 kilometers. At 3 hours, I'm at 120. At 4 hours, I'm at 168. Here's 4 hours, 168. Should just be just below here. 160 is right there, a little bit above 160. Right about there, I have 3 data points. I'll go ahead and connect these 3. Notice my line, my position versus time graph of car B reaches a position of 0 at about this halfway point between 1 and 0 in terms of hours. That makes sense when I look back at I see at half an hour that I'm at position of 0. Half an hour, what's my position? 0. Where do they intersect each other? At about this point right here. Looks like this point. That is just near, right next to the 6 hour mark. Right? So our graph may be just a pinch off. It should be at 6 hours. That's what we know mathematically to be true. But we see that our graph shows pretty closely that at the point of 6 hours, we are both have the same position. Now, what is that position? Well, if we graphed over to the position axis, or the dependent variable axis, we see we're a little bit below 280. Somewhere in between 280 and 260. That's what we see from our data table. Somewhere between 280 and 260. In fact, it's 264. The separation between these two lines, right? This represents that at this moment in time, how far apart are the two cars from each other? We see as time goes by, car B gets closer and closer to car A. Even though both progress in the positive direction, car B, because of its higher speed than car B eventually overtakes car A, and that's at a time of t equals 6.0 hours, and at a position of 264 kilometers. That's when they meet. We see that graphically in terms of when the lines intersect. We see that numerically in terms of the two data tables that we have. Now the last question is, when the cars pass, how long will it have been since car A was at the reference point? Okay, so we have our graph of car A, which is right here. We want to know when did it get to the reference point, right? So the reference point, we can kind of backtrack here. Here's the reference point, right? Because this is the point in time at which it intersects a position of 0, right? As we go down the position graph, we get closer and closer to our reference point. Our reference point of 0, well, when is car A at the reference point of 0? At some point in time right here. Right? Looks like it's a little more than an hour before. Now, though we can't have negative time strictly speaking in this case because we started the clock at some arbitrary point in time, we could say, well, sometime before that time of 0, car A was at the reference point of 0. How will we figure that out? We need to know the function that describes the position versus time for car A. In other words, we need to know this equation. This is the position as a function of time for car A. I put a v in here. For our cases, we would maybe say the speed, we'd say the speed of A times time plus its initial position of A. Okay? And that gives us a function of the position of A as a function of time. If we mean how long it's been from its reference point, when it was at its reference point, what was the position of car A? It was at a position of 0 kilometers. That's when it was at the reference point. If you're at the reference point, then you're at a point of 0 kilometers. Do we know the speed of car A? We do. 36 kilometers per hour. What we don't know is the time at which it was at that point. Do we know the initial position of car A? We do. At time equals 0, that would be the initial position. That's what this x sub A represents. The initial position at our time of 0. Where is car A? Well, we know that he's 48 kilometers down the road. So here's the equation we have to solve. We need to know at what point in time was car A at the reference point of 0 if he's traveling at this speed, and he started at 48 kilometers ahead of the reference point. All we need to do is get time by himself. We'll see that to get time by himself, we subtract 48 kilometers from both sides of the equation, getting t only having one friend left right here. And then if we divide by that 36 kilometers per 1 hour, this is the same thing as saying negative 48 kilometers times the reciprocal here. 1 hour over 36 kilometers, right? If we take a number in the numerator and divide by a fraction, we can change that into a product as long as we take the inverse of the denominator. So this right here is the inverse of our denominator. I'm working from right to left here right now. I see that kilometers cancel, so I end up with a unit that is in time, that is hours. That's what I want, because I'm solving for a time, so I should get units that are in hours. So I see that at a time of negative 48 over 36, that's the moment in time in which he was at the position of 0. 48 divided by 36 gives us a time of negative 1.3 hours. I'll stick with only 2 significant figures here. So that's what this represents here. And remember, we said a little bit more than an hour, right? This would be -1 hour. That's a little bit more than -1. So the total amount of time would be from this point all the way to the point at which they intersect, which would be 6 hours is the point at which they intersect, plus the 1.3 hours before the time began. So we get 7.3 hours is the total amount of time that car A had been driving on the road, had been moving from the reference point of 0 before he intersected car B with car B. All right, thank you.